Hey everyone, let's prove example 7 from the notes, or exercise 20 from section 1.2. We're going to prove that the GCD of A and B equals the GCD of A and B plus any multiple of A, right? And I didn't write this down, but we're going to assume that T is greater than or equal to 1, right? It's pretty obvious when it's 0. All right, so first what we're going to do is we're going to show, first we're going to, let D equal the GCD of A and B, right? That's our standard notation. And then what we're going to do is we're going to show that D, this GCD, divides B plus AT. Okay? And then what we're going to do is that we're going to show that no greater divisor of A and B plus AT exists. So that little d has to be the greatest common divisor. And I'm going to try to make this, maybe I'll try to make it a d like that, because I am going to be using L's. Okay? Since D divides A and D divides B, right, we know that the following is true. B plus AT equals DK plus DLT. Right, you see what we did right there? If we know that D divides A, then we can rewrite it like this. And if D divides B, then we can write it like this, just to be crystal clear. And then, of course, you can factor out the D, and you see that D does, in fact, divide B plus AT. Great. So now all we have to show is that this little d is the GCD of A and B plus AT, right? This part, right? Right? Suppose that there exist for some D, big D greater than, strictly greater than little d, we have that big D divides A and big D divides B plus AT. Okay? Well, then what's going to happen is we have, let's see, on the one hand, B plus AT is going to equal B plus, well, we know that A is a multiple of D, so we'll call that DRT. Again, where are we getting that from? Well, we're getting it from the fact that, big D divides A. But then on the other hand, we're getting that big D, oh, that looks gross. Let's use this guy. Big D divides B plus AT. So this whole thing itself equals D times S. Oh, whoops, now we'll keep this and we'll do that. All right? Well, that means that if we subtract that over, if we subtract the ds over, that b equals drt minus ds, and of course you can factor out the big D. Well, that's kind of problematic, right? Because we said that, because that means that D divides B. But we said that little d was the greatest common divisor of A and B. So since D divides A and D divides B, this means little d is not the GCD. I guess I'll just write does not equal the GCD of A and B. And of course that's a contradiction. Is a contradiction. So big D doesn't exist. Okay? And so that means that little d equals the GCD of A and B plus AT.